Melton demonstrated this amazing phenomenon of marbles disappearing inside a Florence flask when kept in a tank filled with water and viewed from a certain angle. And this phenomenon uses both refraction and total internal reflection. Well, today we are going to be making something called magic films, and the only player at play over here is going to be diffraction, but we are going to see just a similar disappearing effect. Here are the materials I used: OHP films, paper, permanent markers which work on OHP film and won't wash off if dipped in water, sellotape, which is a clear one, scissors, a plastic cuboid container filled with water. Here is the container with water, and we're gonna cut about less than half of the size of the height of the container, a paper, and we're going to cut an OHP film. So this OHP film should be of the same size as of the paper that you've cut, except on one side you're gonna have a little extra OHP film. So this, when we seal the OHP film with the paper, this extra part is gonna play a very major role of trapping the air in between the OHP film and the paper. Next step is to draw. I'm gonna draw house and fire coming out of the house. So just the house is gonna be drawn on the OHP film, and fire, which is gonna be coming out of the house, is gonna be drawn on the paper. Now, once we've drawn the house on the OHP film, put the OHP film on top of the paper, put one finger on the paper, on both the OHP film and the paper, and this OHP film, just pull it up from the other end, use your other hand, pull it up from here and mark the window from where the fire is gonna come. Just make a point over there and then make a fire. So this is how you're gonna make a fire coming out of the window. After drawing, this is how it's gonna look. Now we cut another OHP film of the size of this paper. Here are the layers of our first magic film ready. OHP film at the back, paper middle, and then the OHP film. Now OHP film with the house on it, size should not be too big compared to the paper at the back. As you can see, once I've aligned all the edges, all the three edges, you can see on the left that the margin, the extra margin that I've kept for this OHP film is not a lot, because we want a very thin air film in between these two layers. Now we tape all the sides, and that's gonna seal the whole thing so the water cannot enter and wet the paper or fill the air gap. So we just make sure that the tape does not coincide with the picture on top. Once we have taped it, sealed it from one end, we're gonna cut the excess tape, but we're gonna leave just a very small amount of tape as it is, very close to the edge, just this much on both the sides. And we're going to make sure that that particular part of tape is sealed shut. We're doing this so that the entire magic film is waterproof. That's why we have to make sure that the tapes, extra tape that we are leaving on all the sides that we do, is sealed shut, and there is no way for the water to slither in. This is how it looks, sealed shut. As you can see, there's a little bit of air gap between the OHP film at the front and the paper. If you have any doubts, just put an extra layer of tape to seal it shut. Just make sure that there is some air inside while you're sealing it shut. Now let's see if it works. So here's our magic film in air, and when we dip it and we see it from an angle closer to the just straight up, let's see, and the fire disappears, but from a certain angle it comes back again and it disappears again. Now we make the changing picture magic film. So I've got two OHP films, one slightly marginally larger in size than the other one, again for the purpose of trapping air. This would be easier to trace. You just make an umbrella, an open umbrella on one OHP film, keep another on top of it once the umbrella is dried, and make an umbrella which is closed on top of it so that they both align. Let's tape it. We're going to tape this the same way that we taped the first one, so it's ready. I've also traced out black with on the open umbrella, so the composite image is clearer and better for us to see. Now we dip this in water and see what happens. Here we go. So we can only see, when we dip at this angle, we can only see the open umbrella. The blue marker which we are seeing right now is because I had used blue marker initially to mark both the open and the closed umbrella. Let me twist it and let's see what happens next. So here we can see only the closed umbrella at this angle. So there we go with our two magic films, one with changing picture and one with disappearing one. The challenges that I faced while making these without using laminating sheets is that there is a possibility that the water might get into one of these. In my prototype it did seep through, so it's not 100% foolproof. Another experiment that would be helpful in understanding what's happening is I've traced out letter A on an OHP film, and I'm going to slide this letter along the back wall of the container, and we're going to observe it through this angle. So let's observe what happens to letter A. I'm going to slide it, and it disappears. Now let's slide this letter A through the water along this side of the container. So we're going to put it in the water and we're going to slide it in, and the letter does not disappear. So again, there was an air gap when we slid letter A from the other side of the container along the water. There was an air gap between the OHP film, the container, and the water. Here there was no air gap. We just slid directly letter A into the water. And so this again tells us that air gap is important. To understand what happened, let's see this experiment. Here we are flashing a flashlight near the edge of the water, near the surface of the water, and on the other end we have kept a screen. I've used a notebook at a certain angle. You can see three different areas or three different zones. Zone A, where light is there, and that light is coming in a straight manner through the flashlight directly on top of the paper. Zone B, which is the dark zone, is due to refraction from the edge of the water. So from the edge of the water, the rays which are coming from the flashlight traveling in the air first and then reaching just the edge of the water, they get drastically refracted. and all the rays from below that ray also get drastically refracted. Now that area creates a dark zone, which is the zone B. And the third area, which is zone C, where all the refracted rays are going, traveling from air through the water and reaching the screen, that's again zone B, which is well lit. So what we can learn from this is this creates a darker region. The air gap in between the flashlight or the point light source, the air gap and the water, this creates a darker region, a zone B. And if we see a magic film through that darker region, we'll not be able to see the picture which is behind the air gap. And that's how we created the magic film, which changes the picture, and one which disappears the picture. And also how we couldn't see letter A if we had kept it behind the container. So there was an air gap between the container and the water, and from where we saw it, from the zone B. But if we dip it inside the water, there's no air gap, and the disappearing effect was not there because there was no refraction creating dark zone in that experiment. So that's how it works. That's the working principle of this amazing demonstration. Another interesting experiment that we can do through this letter A is to see the reflection. So we're just gonna dip letter A, and from certain angle we can see the reflection of A